AP Cram, Calculus AP, Free Response Exam Review, Question 52, Real Valued Root Plot, Locating Changes in Sign. Okay, all right, so a particle moves along a straight line for a closed interval where t is either greater than or equivalent to 0 units of time, or t is less than or equivalent to 5 units of time. The velocity of the particle is given by v of t equals -2 plus t squared plus t3, 3t, not t3. Well, you could say it like that technically. All raised to the 6/5 power minus t to the 3rd power. And the position of the particle is given by s of t. It is known that s of 0 equals 10. Okay, this is what you have to do. Find all the times t in the interval between 0 and 5, that is the closed interval 0 and 5. And when I say closed interval, that's just a shorthand way of saying that t is between 0 and 5, including the endpoints 0 and 5, at which the particle changes direction, and justify your answer. All right, this is really a thinking problem. It's more a it's not necessarily a calculation problem, okay? It's more of a visualization thinking problem. So that's a big hint for those of you who are on to a solution. I'll give you a little bit more time to think about it. All right. All right, so in order to find all the times when the particle moving along the straight path changes direction, maybe from west to east, then east to west, you have to consider first where v of t is equal to 0. And if this isn't apparent to you now, I'll show you why in a bit. Therefore, you set v of t equivalent to 0, but you're not really going to solve for the real roots mathematically, because honestly, this becomes torturous. And I know a lot of you might be pissed off at me for not showing this step-by-step process, but that's not what calculus is all about, okay? It's about being strategic, analytical, and efficient with your time. So what you can do is just input v of t. You don't have to put 0 equals v of t. Enter the graphing feature of your graphing calculator, and then do a root plot, okay? So you graph the function, make sure you input it correctly, and then what you're going to do is trace the function for its 0 values, which is pretty, if you're at this level, it's pretty straightforward how to go about doing that. And if you don't know how to do that, inbox me and I'll make a deck of cards to show how you do that, okay? But no, we're only concerned with the close interval between 0 and 5. 5 isn't shown here because there's nothing beyond. There's no more 0 values beyond 4, okay? I'm trying to cut down on pixels. I'm sorry about that. Okay, so here we see that we have 2 answers. All right, and we also note that wherever you have a 0 value, you have a change in sign. So here, v of t goes from being negative to positive. That is, the output goes from being negative to positive, and not the t values or the horizontal x values. And here it goes from being positive to negative, okay? So, and then I want you to notice something here. Here the graph changes direction, but it's still v of t values that are all negative. We're not looking for this type of change in concavity. We're looking for a change in direction, because a negative would denote traveling to the left or to the west, whereas a positive value denotes some sort of speed, or actually velocity, because velocity is a vector quantity containing magnitude and direction. So it considers both the speed and the direction. So this is traveling with some speed to the right or to the east, okay? So these are our answers. All right. So when V of t equals 0, V of t is equivalent to 0 when t equals 0.536033, and when t equals 3.317756 units of time. Okay, when you do a trace, your calculator will give you these answers for your x values when y is equivalent to 0. Okay. The V of t changes sign from negative to positive, again, at time t equals 0.536033 units of time, and V of t changes sign from positive to negative at time t equals 3.317756 units of time. All right, therefore, the particle changes direction at 0.536 ... units of time, and when t equals 3.318 ... units of time. Okay? All right.